Now, we're still not done with testing the booking functionality of this website, because if you paid close attention to when we were using that feature originally, you would remember that there was a lot of data being exchanged between the client and the server until we ended up at the confirmed page. And therefore, that means there is more tests to be carried out. And that's why we usually use the feature as is before we start exploiting it, so that we can see the whole normal flow. And therefore, in the future, even if we discover a bug, we know that there might be more to discover. So again, if I just go to the booking and we're gonna turn on the interceptor, we're gonna fill anything we want in here, just some random data, put a random date, and click on reserve booking. As you can see, this is the original request that we saw, and I told you there is a vulnerability in this, but we're gonna ignore this one. And then we tested these parameters in here in the previous lecture. So we're gonna ignore them this time. We're gonna click on forward. We're gonna click on OK. And now we have another request. So it's a GET request. It's being sent to confirmed.php, and we have a parameter called order ID, and that order ID is equal to a certain value. So this is pretty interesting because this parameter is actually in the middle of a flow. I'm actually just going to send it to the repeater real quick just to see if I send this request as is, what kind of response am I going to get? So as you can see, it seems like we're getting a full HTML page. I can click on the render in here to actually see the page that we're getting. And this seems very similar to the actual page that we were getting. So it's the final result that we were getting when it says the order is pending confirmation, and it shows us the order ID right here. So now we have a parameter and we have an equal and we have a value. So as usual, you should play with this value and try all of the vulnerabilities that we learned throughout the course. But before doing that, this value looks quite interesting. So it's random characters. It doesn't seem like it's an actual word, and obviously it's not a number. You can also see that it ends with an equal sign. And with experience, once you see something that ends with an equal sign, that is a clue that it might be encoded with an encoding that is called base64. Now, the nice thing about Burp, you can simply highlight any text you want, right click, and then you can convert that. So you can encode or decode the selected text. And as you can see, we have base64 in here. And if I'm suspecting that this text is base64, I'm actually going to click on decode to get the original value. And as you can see, the original value is an actual number, and that number corresponds to the order number. So now we understand that the confirm.php file takes a parameter called order ID that is followed by the actual order ID, but the order ID is encoded. So in this case, instead of seeing the actual number, we were seeing the encoded version of the order ID. So just by being curious and just employing this researcher or bug hunter mentality before you even try to discover all of the vulnerabilities that we learned before, and before you start trying to send some payloads in here, let's see what happens if we simply request a different order ID. So instead of this order ID, so this is 69, let's see if we can load the order that was submitted before us. So 68, I'm gonna click on send. And as you can see, this doesn't work. So this whole thing broke and we did not get a useful response. But that's probably because the web application is expecting the order ID to be encoded in base64. Therefore, I'm gonna select my order ID. I'm gonna right click, convert selection again, base64, and this time we're going to encode it. And as you can see now, the text actually seems similar to the original one that we had, and it also ends with an equal sign, because that's what I said before. When you see text that ends with an equal sign, it's a hint that it might be encoded in base64. So let's send it like this, and it looks like it worked. As you can see, we're able to access an order that was submitted by someone else. So in this case, someone that is named Deidre, and we can see her email in here. And therefore, we're actually able to load orders that were submitted by another user, which we're not supposed to see. And therefore, this is an example of a broken access control. And as mentioned before, this is a very, very common bug. Over 94% of websites are vulnerable to it. So the fact that we discovered it in here is not surprising at all. And that's why in pretty much any bug bounty program that I've seen before, you will actually be rewarded a bounty for discovering such bugs, because we're able to load data that belongs to other users. Another thing that should draw your attention is the fact that we're seeing the order ID in here. So I want to see if this value can be manipulated by changing the value in here. So let me just type some normal text like test, and then we're going to encode it to base 64, and we're going to send it, and the website fails to load. So this tells me that this order ID that we're seeing in here is being read from somewhere else. And therefore, if I put any text in here, including JavaScript or HTML text, it's simply just going to break the application. It's not actually going to be displayed in here. And therefore, we can't find a HTML injection or an XSS vulnerability in here. But as you saw earlier, we do have a broken access control vulnerability in which you will definitely be awarded a bounty for.